Welcome back, everybody. In this video, we'll be finishing up section 4.3 on logarithms, basically just by doing some more examples. So these are from a different textbook, not our textbook, so don't go looking for them, I guess. In here, it says, use the definition of the logarithm function to find x. So we're solving an equation, and we want to find x. And so how we're going to do this is by rewriting these in exponential form. I've marked a couple of these for us to do. If you see these in the notes or on the video and have a question about how to do one, of course, send me a message or email and let me know and I'll do it for you. All right, so we're going to try 35 here. Okay, so 35 says the base 4 logarithm of x is equal to 3. Rewriting that in exponential form, that would say 4 cubed is equal to x. And 4 cubed is 64, right? So 64 would be our final answer. Okay, let's try 37. 37 says the natural logarithm of x is equal to 3. If that helps you, you can go ahead and rewrite that as log base e of x equals 3. And then you can rewrite that in exponential form too. So e to the third power is our x. X equals e cubed. For our class, you can leave that as e cubed. Take a look when you do the homework online and see if it says round your answer to 2 decimal places, or are you supposed to enter an exact answer? In general, the further you go in math, the more you want to just leave things as exact answers. And e is kind of like pi in that we don't usually turn it into a decimal unless we have to. So I'm just going to leave that as e cubed. Okay, and let's see, I've got one more over here. This one, it says log base x of 25 is equal to 2. So rewriting that in exponential form, we'll have x squared equals 25. And then taking square roots, x is going to equal 5. Okay, so then an important note here is that it's not plus or minus 5. Okay, the bases for exponential functions have to always be positive, right? Although -5 and 5 are both solutions of this quadratic equation, we're not going to have -5 as a base for a logarithm. So -5 can't be a base. So the solution to our logarithm equation then is just the 5. Okay. So there's a couple of examples there. Here are some more. These ones are from our actual textbook. So for the first group, it just says rewrite each equation in exponential form. We actually already did quite a few of these, so I'll only need to do like 2. Let me take number 11. It says log base 15 of a is b, so 15 to the b power would equal a. Let me do one with an e in it, why not? I'll do 15. Natural logarithm of w is n, so e to the n would equal w. Let me do one with 10. These are fun, I guess. Log 14, log of b is t, so 10 to the t would equal v. Okay, of course we have to go the other direction, wax on, wax off, right? So let's take 18. M to the -7 power is n, so that means log base m of, is it -7 or is it n? It is n, and that will equal -7. It answers the question, what power do you raise m to get n? Okay, and then let's do one with an e in it. E raised to the k is equal to h, so natural log h is equal to k. Okay, one with a 10 in it. This will be common logarithm. It's base 10 log of b is equal to a. All right, what else we got? All right, so we solved some equations by turning logs into exponentials. We're doing that again. So here, log base 3 of x is equal to 2. So 3 squared will equal x. So x is equal to 9. We actually already did enough of that. Here, let's do some simplifying. 36. The logarithm of 100 raised to the 8th power. It says use the definition of common and natural logarithms to simplify. So here, 100 raised to the 8th power. So 100 is 10 squared. So 10 squared raised to the 8th power, that's 10 to the 16th power. So what power do you raise 10 to get 10 to the 16th power? It's going to be 16. So the answer to 36 is going to be 16. For 40, let's do 40. What power do you raise e to get negative 5? E raised to the negative 5.03 power, it's negative 5.03. Okay, let's do some more. These are fun. E raised to the natural log of 10.125 plus 4. Here, the composition of a function with its inverse just gives the identity, right? So you're going to get 10.125 plus the 4. I guess the 4 is just, I'm not sure why that's there. Just to make it more fun, I guess. 14.125. Okay, 38, 2 log. That's tenths, hundredths, thousandths, 10 thousandths. So 2 log, and then that's 10 to the minus 4 power. Okay, so the logarithm of 10 to the minus 4 power is negative 4. So you're going to have negative 8 for that. Okay, and then here we're just using a calculator. No, you can do that. Oh, without using a calculator. Okay, that's even more fun. All right, so here base 3 logarithm of 1/27. Here this is going to be base 3 log of 3 raised to the negative 3. And so that is negative 3. Square roots are fun. Remember that a square root is the same as raising a number to a 1/2 power. So this would be the same as log base 6 of 6 to the 1/2 power. And so that is 1/2. Okay, and let's do one of these. The logarithm of 10,000, that is 10 to the 4th power. So logarithm of 10 to the 4th power will just be 4. And then let's see, logarithm of 1 is 0. 0 plus 7 is going to be 7. All right, so that does it for section 4.3. Let me know if you have any questions on it, and have a great day.